Welcome to a lesson with Dr. Powell. Let's discuss, given the parametric representation of a function, x of t, y of t, is equal to, say, 2t squared minus t, and maybe y of t is equal to t plus t squared, just something simple like this. X of t is this, y of t is that. And maybe perhaps we have a question. When t is equal to 1, what is the slope? Of course, we also need to specify the interval for t if we have a pair of parametric equations like this to represent a curve. Now, if we don't specify t, then we can automatically assume that t could be anything here. So perhaps this is the interval for t. All right, so we have some kind of curve happening. And at t equals 1, what is the slope? Now, what do I mean by slope? The slope as it appears in the plane itself. So this is not like a derivative with respect to t. This is like a ratio of differentials, a dy ratio to a dx, a little change of y per a change of x, a run of y over a run of x. How do we get such a ratio at a point? At the point t equals 1. Well, if we take the ratio, if we're thinking about the ratio of dy dt, and we kind of suppose that dt, a little change in t, is the same, okay, and fixed, then the ratio of dy to dt over the ratio of dx to dt for this fixed value is like a constant, and it's the same constant. And if we can multiply by it in this kind of setting and see that the ratio here of little changes, if we're thinking of these as being tangential changes on a line, and we're just looking at ratios of things, this ratio is going to be the same as this ratio here, assuming, of course, that we're allowing the change of dx to be, well, first the change of dt to be non-zero, and we're expecting that maybe dx, that change would be non-zero as well. Now, if dx is not changing at all and dy is changing, then automatically we know we'd have a vertical line. Okay, so this is kind of what we're looking at, is we're going to be thinking of computing dy dx as dy dt divided by dx dt. Now, these are just calculatable as derivatives, these ratios. And so we go ahead and we compute it. Now, albeit this is intuitive, yet the intuition here serves us well in making the calculation. So dy dx is, we take the derivative of y with respect to t to have, so let's just write this out so we know what we're doing. So to have 1 plus 2t, and dx dt, we compute that to have 4t minus 1. So we have just computed what the slope is on the graph as a function of t. So now we can plug in t as 1, and we'll notice we get, so at t is 1, this is going to be, the top is going to be 3, and the bottom will be also 3. So we'll actually have a slope of 1. Yes, the slope of 1 right at t equals 1 itself. Thanks for watching.